Hi guys, today you're going to be working on Unit 2, Recovery for Quarter 2, and I just want to point out to you that you have a study guide on pink paper. There's a lot of important information on this study guide. As you can see, we have a lot of different topics in Unit 2. I want to point out to you that the topics are listed here in bold, and then there's examples on the right-hand side. So steps or important information is on the left, and examples are on the right-hand side. Use this when you're going through your notes today or the review packet. Also to help you in the future, if you get stuck on WPRs, you can always refer back to these. But now we're going to focus on strictly Unit 2 right now in this video, moving forward with that review packet that says Unit 2, Day 10, Mixed Practice. Okay, so we're looking at this Unit 2, Day 10 Mixed Practice, and we're going to start with just the circled problems. So number 1a says, given the function f of x equals negative 3x plus 5, evaluate the following. Evaluate means to determine a y value. Or determine what the function is equal to. So they give us in this first example f of 0. The 0 is representing an x, which means that we plug that in for x in our first equation, and our only equation in this case. So now we just evaluate this. You could type it all in the calculator at one time if you choose to, or take it piece by piece. It's your choice. But I do want you to type that in your calculator to figure out what f of 0 is equal to. And you should have found f of 0 is equal to 2. Go ahead and move on to f of negative 4. Remember that this represents an x value. So you should have wrote down f of negative 4 equals negative 3 times negative 4 plus 5. Then you're typing that in your calculator. And we get 17. If you want another practice problem here, we can say that this is C, and I want you to find f of, 2. Go ahead and try that if you'd like. Pause the video if you're going to try it. If not, then stay with me. So for that side example over here, I had f of 2 equals negative 1. For number 2, we have given f of x, and then there's a bunch of coordinates. State the inverse of f of x. An important word here is inverse, and that means to switch x and y. So now we have all of these coordinates, and remember that coordinates are always in the order x, y, x, y, x, y. So to find the inverse, we notate it by f raised to the negative 1 of x. Now remember, we've talked before, we don't ever say f raised to the negative 1. We say f inverse. And then we literally take these points, these coordinates, and we switch them. Switch x with y. So put the y value first, the x value second. Go ahead and switch the next two coordinates. So you should have had 1, 5 and 2, negative 6. Again, switching x and y is the inverse. Number 3 from Unit 2 review is where we're given a graph and we have to answer a bunch of questions about it. The first question says, is it a function? In order to test to see if it's a function, we try the vertical line test. Again, to test to see if it's a function, try your vertical line test. So that means up and down lines going through your graph. If it passes, try it again and again, just to be sure. Now I see that my vertical lines only pass through my graph one time every single attempt that I made with these vertical lines. So is the relation a function? The answer is yes. Now the explanation here gets a little bit tricky. Not super tricky, but we have to remember order. So yes, because there is one output for one input. And if you're wondering what input and output mean, output is the y values, input is the x values. There's one y value for one x value. The next question says, if you answered yes to part A, which we did, is the function 1-to-1? Now instead of the vertical line test, we now try the horizontal line test. Where we go left and right. So now I'm drawing in on my graph horizontal lines, and I can see with the first horizontal line that I draw in, it passes my graph in two places, which means that no, it's not 1-to-1. So the explanation goes like this. There is not, because remember we said no, not a unique output for every one input. There is not a unique output or y value for every one input or x value. Again, the important part here is that we're talking about the word unique. We only use the word unique to describe 1-to-1. You'll notice that when we are describing a function, we just talk about one output, one input. When we talk about 1-to-1, we're talking about a unique output for one input. The next one says to state the domain and range using interval notation. Interval notation is where we use square brackets for closed circles, parentheses for open circles, or infinities, positives or negatives. So if we talk about domain, remember that domain means x values and range means y values. So I'm just going to try to clear off what's on my graph so that we can focus on just the domain and the range right now. So domain means x's, and x's go from left to right. So we're thinking, okay, how far to the left does this graph go, and how far to the right does this graph go? And please don't be mistaken, this graph has arrows, which means it goes on infinitely in some particular directions. So if this keeps going up, 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 left, 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 forever and ever and ever, then that means that we have negative infinity as our smallest x value. The farthest we can go to the left is negative infinity. Then if I think about moving towards the right, again, this arrow is taking us forever and ever towards the right, meaning positive infinity. And if we use infinities, then we use parentheses. Next, we have to think bottom to top. How far down does this graph go, and how far up does this graph go? So if I think from the bottom all the way up to the top, up, 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 the lowest this graph is going is here, where y is at 0. But then the highest it's going is way up to the sky, forever and ever, to infinity. So then we say we have 0, comma, infinity. Now we know with the infinity that we use parentheses. However, with the 0, it was a closed circle. And so with a closed circle, we use square brackets. So we have square bracket, 0, comma, infinity. Now the next part, students often get goofed up with this part because they're not sure what to do. So here it says describe the end behavior. As x goes to infinity, y goes to, that's what the arrow means, goes to or approaches. So now we got to figure out what we're talking about here. My graph has all sorts of different colors on it, so I'm going to put one more color here in the mix. We'll go with green. As x goes towards infinity, meaning moving towards the right, as x moves towards the right, where is this graph going? That's the question. Our graph looks like this, and as we move towards the right, the graph is pointed upwards, upwards to infinity. So as x goes to infinity, y goes to infinity. Then if we think about moving towards the left, to negative infinity on the x's, move towards the left, this graph is still rising. It's still going up, 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 up to positive infinity. So as x goes to negative infinity, y goes to positive infinity. Flip this when you've got it. Remember, you can always go back, rewind, and replay if you got stuck on anything here, or if you need more clarification. So we're skipping over number 4, and we're looking at 5a and b. So it says, given the table, answer the following questions. Is the relation a function? Now we just answered this question with a graph, but now this time we have a table. So you could, in fact, plot these points if you chose to, or you can just look at the table and look for repeats. As far as being a function goes, there can be no repeat x's. So if I look at this table, I've got a -4, a -2, a -1, a +1, and a +4. So there are no repeats on the x's, which mean that, yes, this is a function. Then part B says if you answered yes to part A, is the function 1 to 1? Now in this case, again, we tried the horizontal line test last time, and if you chose to plot these points, you can do so. Or you can say, okay, I've got to be 1 to 1. That means there needs to be a unique output for every one input. So that means no repeats on y's. No repeat y's. So if I'm looking at my y's here, I have 2, 3, 4, 5, 6. Are there any repeats? Hopefully you said no. So here, if there are no repeats, then yes, this is 1 to 1. And our explanation is the same as what we saw before. There is a unique output for every one input. Meaning there's a special and different output, y value, for every single input, x value that we have. Moving on to number 7. G of x equals 2x minus 8. State the equation of the inverse. Remember on the first page we said inverse means to switch x and y. And you'll notice here in this equation, g of x equals 2x minus 8. There's no y. But remember that any function, f of x, g of x, h of x, q of x, p of x, whatever it is the same as y. So now we have y equals 2x minus 8. The last time we were working with inverse, we just had coordinates, like points. This time we have an equation where we actually have to physically switch x and y. So now we write this equation as x equals 2y minus 8. And our goal is to solve for y, get y by itself. So the first step here would be to add the 8 to both sides. So now we have x plus 8 equals 2y. Again, our goal is to get y by itself. So we're going to divide by 2, and we're going to do this on each part individually. On the right side they cancel, so now we have y equals, there's technically a 1 in front of this x, so that means we have 1 over 2x plus 8 divided by 2 is 4. So then we just write our final answer in function notation with the inverse. So that means g -1 raised to the -1 of x. That means g inverse equals 1/2 x plus 4. Now if you forget to write it in the function notation with the inverse, it's okay to leave your answer as y equals instead of g inverse equals. You will not lose points if you do that, so it's okay to do so. Number 8 says that we have f of x equals x squared minus 4 and g of x equals 3x. Find or write f of g of x in simplest terms. So it looks like here g of x is inside of f, which means I'm going to circle my g of x function, the expression, and put it inside of f. Notice that when I drew my arrow, I drew it to the x. That's because I want to replace this x, no longer have an x here, and replace it with 3x instead. So we write f of g of x equals, again, no longer just x, but now instead we have a 3x raised to the second minus 4. And because we have to write it in simplest terms, we're going to do just that. Remember that something to the second power is being multiplied by itself. 3x times 3x minus 4. Now you guys know that 3 times 3 gives you 9x squared, because this is x times x. 3 times 3 is 9, x times x is x squared. And then carry down your minus 4. Final answer, 9x squared minus 4. Remember, again, you can pause, rewind, revisit anything from this page by just backing up the video just a little bit if you need to. If you have it and you're good to go, flip forward because we got more problems to review. Looking at number 9, it says, is the relation a function? Go ahead and try this part on your own. I will be doing it on the video independently and silently so that when you're finished you may look up and check your answer. So I found out that this is a function, yes, because there's one output for one input, and the reason that I tested this, or the way that I tested this, was using the vertical line test. Now the next part's asking us if it's 1-to-1. So go ahead and try to answer this. Again, I'm going to write on here as you guys are working so you can check your answer when you're done. Alright, as far as being 1-to-1 goes, the answer is no. And we test this by that horizontal line test. If you draw a horizontal line in here, it passes through your graph 2 times. 1, 2. And then the explanation is that there's not a unique output. Again, that word unique is sneaking in here. There is not a unique output for every one input. Scrolling down, we've got to take a look at number 11 here. It says, given the function f of x equals x minus 5 and g of x equals x squared plus 5, evaluate f of g of 3. So as you can see, g of 3, again, is on the inside of f. So first, we start by finding g of 3. Then, we find f of whatever that value is. First step, g of 3. Now we did something like this part, just this part, on the first page of this review packet, where we just simply plug in 3 for the x value in g function. That's the x squared plus 5. So now we have, instead of x, it's a 3 squared plus 5. When you type that in the calculator, we get g of 3 equals 14. Now we take this value of 14 and we plug it in to the f function. f of 14 equals, again, instead of x, this time we have a 14 minus 5. So then final answer, 14 minus 5 is 9. You have to do two things here because there's two different functions, g of 3 inside of f. So first do g of 3, take that number, plug it into the f function. Flip it over once you got it. Alright, 14 is bringing us into the day 9 content from this unit. So if you're using your study guide, that pink sheet, you can look under stuff that's talking about the key features of a graph. So first step says identify or state the y-intercept. Y-intercept is where we cross the y-axis. So I'm looking up and down on my graph at the y-axis, and I'm looking for where I cross it. And it looks like I'm at this point right here. That point has the coordinates 0, 0. Part B says state the zeros. That means where we cross the x-axis. So again, scoping out on this graph, along the x-axis, I see 1, 2, 3 zeros. And I'm going to actually circle them. 1, 2, 3 zeros. So then I'm stating the coordinates of these zeros. The first one looks like it's at negative 1, 2, 3, 4. Negative 4, comma 0. The next one is at 0, 0. And the last one, 1, 2, 3, 4, 5, 6. 6, comma 0. So again, zeros are where you cross the x-axis. They're also called x-intercepts. Now part E is asking us about relative maximums and relative minimums. Relative minimum means a low point. Relative maximum means a high point. Now if we look at part F, it's also asking about max and mins. But this time we see the word absolute in front of it. Absolute maximum is the highest. The highest point. Absolute minimum is the lowest point. Notice the difference between a high point or the highest point. So as far as part E goes, where we're looking for relative minimums, we're looking for a low point, but not necessarily the lowest. So I'm scoping out, I'm looking down towards the bottom of my graph, I'm looking for a low point, but not the lowest. So I have to decide, is it this one on the left, or is it this one on the right? I'm looking for the one that's not the lowest, which means I'm right here. I'm going to just label this as relative min. And we can state the coordinates of that. That's at negative 1, 2, 3, 4, 5, 6. Negative 6, comma, negative 4. Then we have to look for a relative maximum. So a high point, but not necessarily the highest point. So I'm scoping out the top part of my graph, and I see that I have two potentials. One of them is the highest, one of them is just a high point. Go ahead and state the coordinates and then see if you're correct. I chose 7, 2 because that point is the relative max. It's a high point, but not necessarily the highest. Then part F says absolute min, absolute max. Remember, absolute means the highest, the lowest. So I'm looking at my graph and I'm saying, okay, I know that I picked this point out before as a low point, but was it the lowest? And the answer is yes. So this is the absolute min. Go ahead and state those coordinates. I believe it's at 3, -6. And then for absolute max, looking at the highest point, -2, +4. All right, number 15. Again, asking us if this relation's a function. Go ahead and try to answer this on your own, and I'll do it independently, quietly up here on this video. All right, so I chose to say no, it's not a function, because I see some repeat x's. You can see that I kind of highlighted them or circled them in colors. I see a -4, +2, and a -4, +6. I also see a -2, +3, and a -2, +5. So there's repeat x's, which means no, it's not a function. And there is not one output for one input would be the explanation. Notice again that output is coming first, input is coming second, and we have the word not in there because we chose no as the answer to the relation being a function. Again, if you wanted to, you could plot these points, like -4, +2, -2, +3. You know, we're just kind of guessing here. -1, +4. -2 again is at +5. -4 again is at +6. So if you try your vertical line test here, you can see clearly that it passes through the graph twice. Flip it once you got it. So it doesn't look like we have any questions to do on the next page. You don't need to actually try any of them, except if you choose to, you could try C. Let's flip to see if there's anything on the next couple pages. Alright, so it looks like I tried to circle 20. I'm not sure if it's circled on your papers or not, but it's a good question to do anyways. Go ahead and answer these independently on your own. I will write the answers up here so that you can check it in or check in with it once you're finished. Alright, so my answers are up here. You can read them. You can pause the video, rewind if you need to. If you are struggling to figure out why this is yes and why it's no, go back to your notes, what we just did previously, and also look at your study guide. Alright, and I believe the last question we're going to take a look at here is number 25. So it says state the zeros. Remember that means where we cross the x-axis. I see 2 points where we cross the x-axis. So we're stating -4, 0, and 1, 0. State the y-intercept. That should be easy for you to find. That's where we cross the y-axis. So you're stating those coordinates. 0, 2. And then for the last one, it says state any relative maximums, relative minimums, absolute maxes, and absolute mins. So you want to look for high points, low points, and then decide is it an absolute or is it a relative. Always look at your turning points and endpoints. So if I look at my endpoints, I have this point on the left and I have this point on the right. Then as we look at turning points where the graph turns directions, we have this point up top. So now we have to decide which is which. Is it a relative max, relative min, absolute max, absolute min? So I see that the one and only high point that I have is up here at the top. And this is the highest point, so this means that it's absolute max. So we're going to state that down here. Absolute max. And we're going to state the coordinates. Then I'm looking at the graph again, and I'm trying to decide which one of these two low points is the lowest. How far down, or which one goes the furthest down to be an absolute min. So the lowest is this one on the right, which means that it's the absolute min. We're going to, again, state coordinates. And then last but not least, we have this point on the left. It's a low point, but not the lowest, which means it's a relative min. All right, check your answers for all those coordinates. Make sure you're good to go before we move on. Okay, so number 26, it says we are given two functions, f of x and g of x, and we're asked to evaluate the following. This is something that we have done in the past. Here it says that we have g of f of negative 1. So first start with the inside, then move to the outside. Again, first calculate f of negative 1. And you're going to get a value. Then you're going to take that value and plug it into g. Go ahead and do this. Again, I'm going to do this silently up here on the video. So I found f of negative 1 gives me negative 2, and then I took that negative 2 and I plugged it into g of x. Notice here that there is a negative in front of x, so we have negative 2 plus 1, which gives us a final answer of 3. Looking over here at part C, it says f of g of x. So g of x is going inside of the f equation. So think about that in terms of what you're going to plug in. Continue following through with this problem, and I'm going to do it quietly up here on the board or on the video. So I plugged it in and I have 4 parentheses negative x plus 1 and then a plus 2 on the outside of those parentheses. Remember that we want to get this in simplest terms, so we have to start by distributing the 4. And then, of course, combining any like terms. So final answer for part C should be negative 4x plus 6. And it looks like that's it for this page. All right, so that's actually it for this packet. If you feel as though you need more practice, then please let Miss Wesley know. She should be there with you for boot camp. If you're not doing this at boot camp, then you can always come see me, Miss Griffin. I would be happy to give you more practice, but at this point, otherwise, you're moving on to your unit test. The unit test only has particular questions to do related to the ones that we've done in this packet. If you are not able to pass the unit test, then that means that you have not mastered or at least been successful on the essential skills, which means that we're going to have to do a little bit more work before we can change our grade or recover quarter two. Because if you are not passing the essential parts, then you're not doing what you need to do or being successful in what you need to be successful in order to pass the quarter. So again, if you need to rewind this video at all, please feel free to do so. Moving forward, you're working on that unit test. Good luck.